What's up, geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to be looking at lesson 7.3, proving that a quadrilateral is a parallelogram. We're going to be able to identify and then verify all the parallelograms and then show a quadrilateral is a parallelogram using the coordinate plane. First we want to focus on is from our theorem sheet for chapter 7. We're looking at parallelogram, opposite sides converse, and then opposite angles converse. So it just says is if AB is congruent to CB and BC is congruent to DA, then ABCD is a parallelogram. That just means both pairs of opposite sides are showing that they're congruent to one another. And then the same thing is true for the opposite angles converse. AC is congruent and BD is also congruent, then ABCD is considered a parallelogram. So as we look at our first example, it says an amusement park ride has a moving platform attached to 4 swinging arms. This platform swings back and forth higher and higher until it goes over the top around in a circular motion. I'm sure some of you have maybe been on a ride like this before. In the diagram below, it shows that AD and BC represent 2 of the swinging arms. And notice that AD is matching BC. And then DC is parallel to the ground, or line L. Notice that DC is also matching AB in the length. Explain why the moving platform AB is always also parallel to the ground. This is where we maybe want to type a few things. So we could say, since both pairs of opposite sides are always congruent, ABCD is a parallelogram by the parallelogram opposite sides converse, and AB is parallel to DC, and DC is parallel to line L. So AB is parallel to line L using the transitive congruence property. Okay. Next, we have some algebraic reasoning. For what values of x and y is quadrilateral PQRS a parallelogram? So first off, I can maybe say that 2x minus 1 is equal to x plus 9. And I'm just going to move my constants to one side and my variables to the other. I'm going to get x is equal to 10. And then for my y's, if I know x is equal to 10, I can say y is equal to x plus 7, but plugging in that 10 for the x. So I'll get y is equal to 10 plus 7, or 17. Up next, we have 2 additional theorems. So if we're continuing to look at that theorem worksheet I gave you, 7.9 states the opposite sides parallel and congruence theorem. If one pair of opposite sides of a quadrilateral are congruent and parallel, then the quadrilateral is a parallelogram. So this is just going on top of what we just talked about with 7.7. And then the parallelogram diagonals converse states, if the diagonals of a quadrilateral bisect one another, then the quadrilateral is also a parallelogram. And again, that is kind of what we saw before in lesson 7.2 with that diagonals and consecutive angles. Okay, so we're going to look at this one. It says the doorway is shown as part of a building in England. Over time, the building has leaned sideways. Explain how you know that SV is equal to TU and that the angle S is congruent to angle U. So the first thing we can state is since ST is equal to UV and ST is parallel to UV, STUV is a parallelogram by the opposite sides parallel and congruent theorem. So SV equals TU by the parallelogram opposite sides theorem. So since STUV is a parallelogram, we can conclude that angle S is equal to angle U by the parallelogram opposite angles theorem. Okay? Going onward, we have some more algebraic reasoning. For what values of x and y is quadrilateral ABCD a parallelogram? And then explain your theorem, or explain your reasoning. What I'm looking at here is we're probably going to be able to use the parallelogram opposite angles converse. Okay, so that means 4y is equal to y plus 87, and 3x minus 32 is equal to 2x. Okay, so what I would do first let's start with my x's. I'm going to get all my x's to one side. I'll get negative 32 is equal to negative 1x, or x equals 32. And then for my y's over here, moving my 1y over to get 3y is equal to 87. I don't know why I wrote 8x. Dividing both sides by 3, I'm going to get y is equal to 3 over 8 twice with 2 left over, 29. Okay? Number 3, 4, and 5. State the theorem you can use to show that the quadrilateral is a parallelogram. So for number 3, we can use the opposite sides parallel theorem and congruency theorem. For number 4, we can say that the parallelogram opposite sides converse. And then for number 5, we can do parallelogram opposite angles converse. Okay? For number 6, for what value of x is quadrilateral MNPQ a parallelogram, and explain your reasoning. So MNPQ is a parallelogram using the parallelogram diagonals converse, and that just states that my diagonals of 2x are equal to 10 minus 3x. So as I solve for x, I get 5x is equal to 10, or x equals 2. Okay? Last little portion, ways to prove a quadrilateral is a parallelogram. We're going to show that both pairs of opposite sides are parallel. We remember we can do that by finding the same slope. We can show that both pairs of opposite sides are congruent. That's called using the distance formula, or just counting if you can count it. We can show that both pairs of opposite angles are congruent using that parallelogram opposite angles converse. We can show that one pair of opposite sides are congruent and parallel, and we can show that the diagonals bisect one another, also being able to use the distance formula. So we're going to talk about this one, show that the quadrilateral ABCD is a parallelogram. So what we want to be able to do is focus on what reasonings we can use, and I'm thinking if we just show that one pair of opposite sides, so number 4, are congruent and parallel, then we can prove that's a parallelogram, because it kind of like two birds, one stone type of deal. One pair of opposite sides are congruent, and also talk about their parallel. So instead of doing all sides slopes and all sides to see if they're congruent or not, we can just talk about 2. So let's maybe look at AB and CD. Okay, starting with AB first, we're going to look at the slope, and since I have a picture, I'm just going to count from B to A. I'll go up 2 over 2, so that's 2 over 2, which is equal to 1. And then CD, the slope, I go from C to D up 2 over 2, so that's 2 over 2, which is also equal to 1. So I've just proven that they're both parallel. Now I just need to prove their lengths. Okay, so I would just use the distance formula for this one, starting with AB. So I would take my x2 minus x1, so I'm just going to do 0 minus negative 2, which is 2, and then my y2 minus y1, 0 minus negative 2, which is also 2. Squaring that, I got 4 plus 4, which is equal to 8, and the square root of 8. If you wanted to find the decimal of that, but I'm going to leave it in square root form first to see if that matches. Then I'm going to find the length of CD. So I have my x2 minus x1. I'm just going to do 4 minus 2, which is 2. And then my y's -2 minus -4, which will still give me 2. And I'm still ending up with the same square root of 8. Okay, so I used reasons. I used number 4, and I also could technically use reason number 2, show that both pairs of opposite sides are congruent. So the parallelogram opposite sides converse and the opposite sides parallel and congruent theorem. Okay, so really that's all you have to do, because then I just did one pair of sides. If they're already congruent and parallel, then the rest of it would also be parallel and congruent. That's all I had for today. Thanks so much for tuning in, and we'll catch you next time. Have a great day.